All right, today we're going to look at reflections, which is our second type of transformation. So we are going to write a rule to describe the reflection of an image, and then we're going to reflect an image given a rule. All right, so what is a reflection? A reflection is a flip over a line called the line of reflection. So typically we think about a reflection like a mirror image. It's like the image is flipped to the opposite side of whatever that line of reflection is. Each point and its image are the same distance from the line of reflection. So here I see that B is this far away from the line of reflection, so then B prime is the same distance away on the other side of the line. Typically we use the x-axis and y-axis as common lines of reflection. And then when we reflect an image, the result is going to be congruent polygons. So meaning the polygons are going to be the same shape and same size. All right, so let's look at one. We've got triangle ABC, and I'm going to go ahead and draw these coordinate points on my coordinate plane. All right, there's the origin. All right, so 1, 6, I'm going to go right 1, up 6. And remember, we're going to label the letters as we go. Label the points. All right, B is 8, 3. So I'm going to go right 8 and then up 3. And that's point B. And then point C is 4, 2. 1, 2, 3, 4, 1, 2. All right, and then I'm going to connect my points. You can use a ruler. I don't have a ruler, so I'm just going to do the best that I can. And it's not going to look perfect, but that's okay. All right, there we go. Okay, so our goal is to reflect across the x-axis, meaning the x-axis is my line of reflection. So think about where the x-axis is. The x-axis is this one right here. Okay, so this is my line of reflection. And each point on my pre-image, which is my original shape, this is my pre-image, should be, I'm going to see how far each point is away from my line of reflection and then go that distance on the other side to get my image. So let's start with A. I'm going to count A as 1, 2, 3, 4, 5, 6 away from the x-axis. So it's 6 above the x-axis. So to reflect it, I'm going to go 6 below the x-axis. So I'm going to go 1, 2, 3, 4, 5, 6. That's my new point. And since that's A reflected, that's going to be A prime. All right. So the coordinate of A prime, it's A was 1, positive 6. A prime is 1, negative 6. So I'm going to go ahead and put that here. Okay. All right. Let's go to B next. B is 1, 2, 3 away from my x-axis, and it's 3 above the x-axis. So I want to go 3 below. So 1, 2, 3. And that is B prime. Okay, B was 8, positive 3. B prime is 8, negative 3. All right, and last one, C is 1, 2 away from the x-axis, so it's 2 above, so I want to go 2 below, and that gives me C prime. So instead of 4, positive 2, C prime is 4, negative 2. And then, of course, I'm going to connect my points. Okay. All right. So as you can see, it's like my triangle just flipped upside down across that x-axis. Okay. And we're going to come back to these points in a second and look at a general rule. Let's look at number 2, or this next one, which is number 4. I'm going to go ahead and plot my points. This time it's going to be a trapezoid, so I have 4 points. X is 4, here's my origin. Okay, X is 4, negative 1. So 4, negative 1. Again, I'm going to label, that's X. Y, oh, I skipped one. W is 2, negative 3. So 2, negative 3. It's W. Y is 8, negative 2. So over to the right, 8, down 2. And then Z is 3, negative 7. So right 3, down 7. Okay. Then I'm going to connect my dots. All right, there we go. There's our original trapezoid, which will be the pre-image. Okay, this time I want to reflect it across the y-axis. So think about where the y-axis is. The y-axis is the one that is vertical, going up and down. Okay, so I'm reflecting across that y-axis. So same idea as last time, but this time instead of flipping it from above the x-axis to below the x-axis, this time we're flipping it across the y-axis. So since the whole shape is on the right of the y-axis, when I flip it or reflect it, it should end up on the other side, the left side of the y-axis. All right, so I'm going to do 1 point at a time. I will start with, let's start with W. So W is 2 away from my y-axis on the right side. So I'm going to go 2 away on the left side. So 1, 2. And then that is W prime. So W prime, W was to -3. W prime is -2, -3. All right. Next, we're going to do X. So X is 1, 2, 3, 4 away. All right, so X prime would be 4 away on the other side of the y-axis. So 1, 2, 3, 4. And that is X prime. All right, so X prime. All right, so X prime is, instead of 4, -1, is going to be -4, -1. Okay. Let's start comparing. So W was 2, -3. W prime was -2, -3. The only thing that changed was that X value, right? It changed from a +2 to a -2. X went from 4, -1 to -4, -1. Again, the 4 just became negative. All right, we're starting to see a pattern here. Let's go Y next. So Y is 8 away from that y-axis on the right side. So I'm going to go 8 to the left to reflect it. So that's Y prime. So for Y prime, instead of 8, -2, it is now -8, -2. And again, I see the Y value stayed the same, but my X value changed from +8 to -8. All right, let's see. Let's see if I can predict. So Z is 3, -7. Based on this pattern here, it looks like all of the X values are changing signs. So they all started as positives and are becoming negatives. So look at 3, -7. My Y value is going to stay the same and it's going to stay -7, but I think my X value should go from +3 to -3. Let's see if that works. So -3, -7, -3, -7. And that's Z prime. Turns out that worked because Z is 3 away on the right from the y-axis, and then Z prime is 3 from the y-axis on the left. All right, so there's kind of that pattern happening here. So let me connect my points, and then we're going to look at kind of a general rule for all of our reflections. Oh, that was a bad line. One more time. All right, so connecting. All right, close enough. You get the idea. So our two shapes, our pre-image and our image, are flipped across the y-axis. Okay, so let's look for a general rule here. We said for the y-axis, all of our x values are changing signs. They all start, in this example, they all started as positives and they all became negatives. But the y values all stayed the same. Okay, let's look at what happened. Let's go back to this example. We flipped it across the x-axis, and it went from 1, 6 to 1, -6. B went from 8, 3 to B prime 8, -3. And then C went from 4, 2 to 4, -2. So when we reflect across the y-axis, the x-axis, the y values become their opposites. Just like in the other one. So x-axis means the y values change, they become the opposite. When we flip across or reflect across the y-axis, all of the x values become opposites, right? So that leads us to our rule, which says if we reflect across the x-axis, that's what that R means, reflect across the x-axis, then xy, the point xy, will become, we said if we reflect across the x-axis, then the y value changes. So x stays the same, but y is going to become negative, right? And then opposite, if we reflect across the y-axis, then the y stays the same, but the x becomes negative, okay? And just a side note here, we say it becomes negative, but think about if we start with a negative value, then it's actually going to become positive. So really, it becomes the opposite of what it started as. All right, so let's see. This one says I'm given point L is -8, -2, M is -3, -1, N is -1, -8. And it undergoes a reflection with these new coordinate points. And then I'm supposed to name the line of reflection. So I'm deciding, is it going to be the x-axis or the y-axis that we are reflecting across? Well, let's look at L goes from -8, -2, and it becomes L prime, which is 8, -2. I'm just going to kind of compare them side by side. M is -3, -1, and it becomes M prime, which is 3, -1. And then N is -1, -8, and it becomes N prime, which is 1, -8. Okay, so every single time, let's look at what happened. -8 changed to a +8, so the x changed signs. The -2 stayed the same. Okay, so -3 in letter M became +3, so the x changed signs, the y stayed the same. And then in letter N, -1 became +1, the -8 stayed the same. So since the x values all became opposite, or they changed signs, what do you think happened? We reflected across the y-axis. So this is reflected across the y-axis. So it's kind of the opposite. If the x changes signs, we're reflecting across the y-axis. If the y changes signs, we're reflecting across the x-axis. All right, try some on your own.